Hello, Mr. Eric, Mr. Ryan, right?
Yeah.
Okay, so we are given the integer n. We want to find out the sum of all the numbers between 1 to n inclusive if this number can be divisible by 3, divisible by 3, 5, or 7. Okay, so we're given the integer n. We want to find out the sum of all the numbers between 1 to n inclusive if this number is divisible by 3 or 5 or 7.
N?
Yeah, for example, let's say if we given an integer 10. Okay.
Yes.
So consider the numbers from 1 to 10 inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which number is divisible by 3, 5, or 7?
1,
It is these.
3, 1,
Why is
5, 5, 7.
1?
Yes.
1 is not divisible by any of those.
Five.
Okay. 3,
5,
5, 6, 7. And that's
10.
it. 10, yes. And 9. So we just added up these sum together. These numbers together. Okay, so what is your thoughts?
40.
Yeah, I know.
Yeah.
So what's the solution? What's the strategy to do that?
How do we get the numbers again?
You know, given an integer n, we just want to find out the sum of all those numbers that can be divisible by 3, 5, or 7.
Why 3, 5, and 7?
This is the question. Any
Just
idea?
do the maths.
Just do the math, yes. We just did it, right? This is one approach. We just did it. We're given the n. We know the numbers. We try each one to see if it can be divisible by 3, 5, or 7. If it is, we add it to the sum, right? This is one solution. Define f n. Answer equals 0. For I in range, start from, we don't need to check 1 and 2, right?
Yeah.
Because the minimum is 3, right? So we just check from 3 to n plus 1, actually to n inclusive. If this number I, right, can be divisible by 3 equal 0, or I divisible by 5 equal 0, or I divisible by 7 equal 0, then answer plus equal I. Return answer. Do you understand this? This is pretty simple. We go through the numbers from 3. Why do we start from the number 3, not 1 or 2?
Because 1 and 2 are not divisible
By any
three.
rules, yes. We can just skip those two
You
numbers.
can do it just by the smallest number.
Yeah, 3 to n plus 1. N plus 1. This is exclusive, right? So it's n inclusive. Make sense? Yeah? You know this for loop, right? And for each number, we check if it can be divisible by any of those 3, 5, 7. If it is, we add it up, accumulate answer. What's the time complexity for this one? Oh, what? O-N. Yeah, O-N. Simple. This can be turned into one number. Return sum. Okay? Return sum. I. This go here. For I in range from 3 to n inclusive. If here, right? Okay, time complexity O1, space complexity O1 constant. It's so simple, right? What's the point? Okay, the point is that we can use the Venn diagram. Alright, you talk about this Venn diagram. Venn diagram. What's Venn diagram? Explain one sentence. What's Venn diagram? To mommy. Mommy.
2 circles.
What's Venn diagram?
A Venn diagram is a diagram with the it's hard to explain in with one sentence.
Okay, then 2 sentences.
The Venn diagram is a diagram. It has circles in it, and you place lemons. And each circle has what it is, and then you.
What are we doing with this Venn diagram? What is it used for?
Used for putting things in, and there's some circles which overlap each other, and then you can put it in between in that overlapping parts, so it's in more than one.
Okay, so what kind of data structure in Python can we use to simulate this Venn diagram? What kind of data structure is useful to do this Venn diagram stuff. You know. Any idea? It starts with S.
String.
3 characters. It starts with S.
Square.
A data structure.
Sentence. Square language.
S.
SQL.
The data structure. S what T.
Set.
Yeah, hash set. Right? Remember we talked about set intersection. Okay. Okay. So set stores unique numbers. Right. Look. This circle. Yeah. Let's say it represents the numbers that can be divisible by 3. Okay?
Yeah, that's what I'm saying. Is
Okay? This circle, let's say it represents the number that divisible by
5.
5. Yes? Okay, so what's this in common?
It's 3 and 5 is the overlapping part.
Overlapping part, which is divisible by
3 and 5.
a number is 15. Yes. Okay. So, okay, I'm going to do this. What's here? Divisible by
7.
7. Okay?
And then this part right here
Is
is divided by 3, 5 and 7.
so what's this number? Yeah. 3, 5, 7.
105.
Can I have it?
Okay.
3, 5.
105.
105. Okay, so this part is 15, right? And this part is 5 and 7. This part is
35.
and this part is
21.
21. Okay. So why do we need this Venn diagram? Right? The circles. We want to find out the sum, right? Let's say we use the f function. F3 means the sum. F3 means the sum of all the numbers that can be divisible by 3 in the range. Okay? And then plus F5, which is the sum of all the numbers, this circle, right? Divisible by 5. Plus F7, which is all the numbers that can be divisible by 7. Okay, so now we are overcounting, right? Do we have overcounting here?
Yes.
This circle plus this circle plus this circle. Do we have overlapping?
Yeah.
Yes.
Which part we need to subtract?
The
I added
middle
up.
part. The middle part.
So which is minus which one?
Minus 3 and 7. 3 and 5. 5 and 7.
Minus this one, and this one, right?
Yeah.
F15 minus F21 minus F35. Okay, so look, adding up this one, right? And then subtract this one, and this one. Is there a problem? Which part we need to add it back? Which part we have deducted more than necessary? Can you imagine? Look, these 3 circles, right? Add it up together, and you say we need to deduct these 3 parts. We take away this bit, we take away this bit, we take away this bit. Okay, so which part we have deducted more than once?
105.
Yes. Okay, so look, just imagine 2 circles. This one plus this one. Overcounting, right? So we have to deduct this bit, right? Yes? Because this bit is added twice, am I right? Yes?
Yes.
Okay, same here. This bit and this bit, and this bit, there are 3. So if we add it up, let's count. Let's do the counting, okay? Let's do the counting. This bit and this bit, add it. So here, I added twice here, alright? This bit and this bit, I added twice here, right? Yes? This bit and this bit, added twice here. But here, this bit, here, there are 2, right? 2, right? But here, this should be 3, right? This common part has been added 3 times.
Why?
You don't see this, right?
No.
This common part, how many times it appears? How many times it has been added? 1, added 1, added 1, 3, right? Is this 3? Because these 3 circles intersect here, right? So this is 3, right? Yes? This part and this part, how many bits here, right? This is 2, right? Because when you add this circle and this circle, this has been added 2 times, right?
Yeah.
I put another one, so this is the same, right? Here this is, but this bit has been added 3 times, right? Because it appears in 3 circles. Make sense?
Yeah.
Yeah, okay, so this time has been added 3 times. So ideally we just want the 1 times, right? 1 for each one, right? Yes?
Yeah.
This bit plus this bit plus this bit. And I need to subtract this bit, subtract this bit, subtract this bit. But when you subtract 3 times, right? You subtract 3 times of this. So this makes 0. I want the 1 times. Yes? I want the 1 times. I have to put it back. So plus F 105. Make sense, yes? Can I repeat it one more time? Okay.
No.
Does it make sense?
Good.
Yeah.
Okay, let me repeat, okay?
No.
So the numbers means that it has been added by this. Am I right?
Yeah.
So ideally I want these numbers to become only ones, added ones, right? So 2, 2, 2, I have to subtract them, right? Yeah? To make it ones. So now it become ones. But the thing is that you subtract 3 times. When you subtract these has gone from 3 to 0. Right? But I want 1 times here. So let's put it back. Yes?
No.
Okay? Make sense? Does it make sense now?
Why can't you like subtract this? Just
Okay, it's hard, right? This is not regular. We only know this circle and this circle intersection, which is this bit. Right? The thing is that the beauty of the Venn diagram is the intersection, you know it. This f function is the sum of all the numbers in a range from 1 to n that can be divisible by that, right? And we can use the Bruteforce for that, right? But that's going to take time, am I right? Look at this f. Do you understand this bit, right? Everywhere. Come on.
Yeah.
You understand this bit, okay? So how do we implement this f function? Define f a. Okay. We want to find out all the numbers between 1 to n, actually to 3 to n, right? That can be divisible by this number a. So divisible. Answer equals 0. For I in range 3, yeah? Actually we start from a, right? Start from a to n plus 1 n inclusive. If I divisible by a can be divisible by a, then answer plus equal I. Return answer, right? Yes? F function means that we want to find out all the numbers between a to n inclusive. If this number can be divisible by a, then we sum it, right? Okay, so using this function, this is still on, right? And then we can do the math. The problem with this one is still takes on iteration. We can improve it, right?
How?
Good question. How do we improve it? Look, 10. We want to find out, let's consider this. We want to find out all the numbers between 1 to 10 can be divisible by 3. How do you calculate this number? There are 10 numbers here, okay? We want to find out how many numbers can be divisible in the range by 3. You know, actually from 3 to 10. How many numbers can be divisible by 3? 3, 4, 5, 6, 7, 8, 9, 10. Okay, which numbers are divisible by 3?
3, 6, 9.
Okay, how many numbers are there? 3, yeah? Yes? You know that, right?
Yes.
Okay, so let's say how many numbers can be divisible up to 100?
43.
Yeah, you don't do this stupid counting, right? You don't do this counting, right? You can do this math, am I right?
Yeah.
How do we get the math? So this number, 3, 4, up to 100, right? So the lower bound is 3. The upper bound is 99. So this sequence is 3, 6, 9, 12, 15, blah, 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 till 99, right? The distance between neighboring numbers is 3. So we want to find the sum of these. Okay, so 1 plus 2 plus 3 plus 4 plus till 100. You know that, right? What's the sum?
50-50.
50-50, right? This is called I don't know how to... Arithmetic, right?
Arithmetic.
Yeah, I don't know how to progression.
RIF.
Yeah, AP numbers, right? So every neighboring distance is the same. So we can use the formula, right? The first item plus the last item plus how many of them, right? The first item plus the last item times how many of them divided by 2, right? We know that, right? So this is the same thing. The lower bound we know. The upper bound we can calculate. How many numbers we can calculate divided by 2? Yes? Make sense? Does it make sense now?
Yeah.
Yeah? Okay, so now we can replace this function, right? Replace this function. Define f(a), right? The lower bound L equals a, right? The lower bound is a, that's for sure, am I right? Yes? The upper bound, how do we calculate the upper bound? 100. How do we know 99 is the upper bound? Now the lower bound is 3, right? Start from 3. The upper bound, this is given this 100, right? We know this number is n. So how do we get the 99?
We know 100 is not in the 3 times tables.
Yeah, but how do we get the 99?
We go down the maximum 2.
Yeah, you are here. Yeah, that's good. We can go backward, but we can do this math, which is n divided by a, right? Look, 100 divided by 3, which is 33.333, right? Yes?
No, 100 divided by 3.
100 divided by 3, this is 33.333. But if we're using the integer division, which is 33, right? Get rid of this. Now this is 33. And then times 3, right? Times a. This is the integer part. Times a, and that's 99, right? 33 times 3, 99. Okay? Now we have the upper bound. How many numbers between lower bound and upper bound? The count equals higher bound minus lower bound, right? Divided by the distance. Each distance, right? Each distance is a plus 1, right? Yeah, because the lower bound is always 1 number, am I right? The total numbers between this range, which is 99 minus 3. How many numbers? 99 minus 3 is 96 divided by 3, which is 32 plus 1 number, which is 33. Yeah, you are right. 33 numbers between 3 to 99. Okay? Okay, now I have these 3 parameters. Lower bound, higher bound, count. And what's the sum? What's the sum? The sum is the first number plus the last number times how many of them divided by 2. Right? This is the equation, right? The same as we compute the sum between 1 to 100. Am I right? Yes?
Yeah.
Okay, so now that's it. What's the time complexity for this function?
01.
01, okay. What's the time complexity of this one?
01.
Okay, so overall 01. Which one is better?
01.
Obviously, right? We just calculate it. The previous one, it takes OA iteration, right? What's the previous? What's the Bruteforce? What's the first solution? 100, right? Let's say 100. We just check from 3, okay? 3, 4, 5, 6, up to 100. Which number can be divisible by? Which number is divisible by 3, 5, or 7? Okay, it is. Then we add it up to the sum, right? Because it takes n iteration, right? Roughly, alright? Does it make sense? But for this one, FA, we are calculating the numbers between 1 to n inclusive. Which number can be divisible by a? And we sum it, right? And using this function, we can do this Venn graph. Make sense? Yeah, remember this Venn graph thing, yeah? This can be divisible by 3. This can be divisible by 5. This can be divisible by 7. So ideally, I want to add this bit. Yeah, I added this circle, I added this circle, I added this circle. But these 3 parts I have added twice. These 3 parts I have added three times. And I subtract. Right? I subtract 1 time here. I subtract 1 time here. I subtract 1 time here. But when I subtract these separately, I subtract the middle part, which is the common intersection, 105, 3 times, which make it 0. So then we have to put it back. F 105. This is very important. We have Venn graph. The first time we're using the Venn graph to solve the problem using the Venn graph, mathematics. Make sense?
Yeah.
Yeah.
Okay, so what have you learned today?
So the Venn diagram, we have these. We have numbers where F thingy, and then you put the numbers 3 to n, and then you just to get all of them once, since there's duplicate, so we subtract the overlapping since there's 3, 3, 5, and 7, you said it was complicated to do not to separate it from the center, so you have to subtract it from the center 3 times. When you're subtracting the overlapping parts from in between 2 circles, you're also subtracting the center, and there's 3 circles, so then it'll be 0, so you have to add it on again.
What's the F?
If the multiples you have to divide by is the numbers that you have to divide by for the numbers to n.
We want to find out the sum of all the numbers in the range that can be divisible. So F function, F3, what does it mean?
Yeah, is circle that is uniquely divisible by 3.
The sum of all the numbers in the range that can be divisible by 3.
Yeah, that's
Okay.
what I'm saying.
Okay, good job. Okay, let's see for today. Bye bye. Bye bye.
Bye.
Bye.